Hello everyone, myself Hans. Today we are going to solve the given problem from topic multiple integrals. Question is given, evaluate the integral. Integral limit is 0 to a and the second limit is given by 0 to under root of a square minus of y square, and given under root of a square minus of x square into y square whole bracket close dy dx. Let's solve the problem. Given integral is this is taken equal to I, and this is given by 0 to a, and the second limit is 0 to under root of a square minus of y square, and here given a square minus of x square minus of y square under root, and this is dy dx. First we have to integrating with respect to x. This is given integral limit is 0 to a, and here we can also write the given integral here. This is written as integral limit is 0 to under root of a square minus of y square, and under root of a square minus of x square and minus of y square is written as under root of a square minus of y square का whole square minus of y square and whole square, and this is with respect to integrating, this is dx and here is whole dy. When we squaring under root of a square minus of y square, here we have to take in this is x square. When squaring under root of a square minus of y square, we get here a square minus of y square and minus of x square, we get the above result. And further from here we have to using the formula integral of under root of a square minus of x square dx is given by x by 2 under root of a square minus of x square plus of a square by 2 sin inverse of x by a. We have to using this formula to further simplify the given problem. This is written as I is equal to integral limit is 0 to a here, and we have to expanding here under root of a square minus of y square is taken here a under root of, let's suppose a is under root of a square minus of y square and x is x, so we have to expanding, we get here x by 2, so we have to write in here x by 2 under root of a square minus of x square. A is under root of a square minus of y square, on squaring we get a square minus of y square and minus of a square minus of x square, here x is taken minus of x square plus of a square, here under root of a square minus of y square, on squaring we get here a square minus of y square by 2 sin inverse of x by a. Here x is x and upon a is under root of a square minus of y square, x by 2 under root of a square minus of x square plus of a square by 2, here a is under root a square minus of y square, on squaring bit here a square minus of y square, and this is dy. And further we have to putting the limit also here, limit is 0 to under root of a square minus of y square. We have to integrating the given function first with respect to x, so we have to putting in place of x under root of a square minus of y square. So we have to getting here I is equal to integral limit is 0 to a, and here we can put the limit here in place of x, we have to put in under root of a square minus of y square upon 2 under root of a square minus of y square in place of x, we have to put in here once again a square minus of y square, a square minus of y square in place of x, we have to putting the limit here under root of a square minus of y square, on squaring we get here a square minus of y square plus of a square minus of y square by 2, and here is sine inverse. In place of x we have to putting under root of a square minus of y square upon under root of a square minus of y square. When we have to put lower limit, we get the all 0 here. So we have to not put in the lower limit and whole dy, and from here under root of a square minus of y square under root of a square minus of y square is cancelled out. Then remaining is here integral I is equal to integral limit is 0 to a, and here we have to solving under root of a square minus of y square upon 2, and from here we have to solving under root of a square minus of y square and minus multiply with this bracket, this gives minus of a square and plus of y square, minus of a square and plus of y square, and here is plus of a square minus of y square upon 2, and here is 1, and we know that the value of sine pi by 2 is 1, so we have to putting in place of 1 sine pi by 2, so we have to writing here sine inverse of sine pi by 2 and whole dy, and from here a square minus of y minus plus of a square minus of a square is cancel out, minus of a square and plus of y square is cancel out, then this portion becomes 0, and further we have to solving integral I is equal to integral limit is 0 to a, and here remaining is this portion becomes 0, then a square minus of a square is 0 and y square minus of plus y square is get 0, then whole portion is 0, that remaining is here a square minus of y square by 2, and from here sine inverse 2 sine is removed, so we have to get here pi by 2, and this is whole dy, and further we have to solving and integrating with respect to y, taken pi by 2 into 2, we get here pi by 4 is taken outside, and here integral limit is 0 to a, and a square minus of y square into dy, and here we have to integrating with respect to y, this is given by I is equal to pi by 4, and here a square dy, on integration of dy we get here y, so we have to writing here a square y minus of y square dy, on integration this gives y cube upon 3, and integral limit is 0 to a, and here we have to put the limit, upper limit we have to putting the upper limit, this is integral I is equal to pi by 4, and here in place of y we have to putting a, this gives a square into a, this gives a cube minus of a cube upon 3, and further we can solve here, this is integral I is equal to pi by 4 into, here taking LCM 3a cube minus of a cube upon 3, and from here we get 3a cube minus of a cube, we get here 2a cube, pi by 4 into 2a cube upon 3, and from here we have to cancel out 2 to the 4, and we get the required result here pi into a cube upon 6. This is the required solution of the given integral. Thank you class, and thank you for watching.